Can you see my screen?
Yes, I can see your screen.
All right. I'll assume everybody can see my screen. So I'm sorry also about yesterday. Should have checked with Mira and make sure we're on the same time, but now we're here. So my talk will be about extending Kubernetes. Kubernetes is a huge system, as you know, and it has tons of ways to extend it and expand it and make it even bigger and more customized. So it will be a very kind of a whirlwind tour where we'll go over many things, but we'll just mention them, and each slide in this talk, you can do a whole other just a talk or even a workshop about it. So don't be too overwhelmed. This is more about kind of getting the idea of what's possible and what is available as Kubernetes. So first, let me and I've been a software engineer for many years. I started 1,000 years ago in the previous millennium, and I wrote a book about Kubernetes, 2 editions actually, Mastering Kubernetes, and also I wrote hundreds of technical articles. I like to write, and this is how I learn new things. I also have several years of hands-on experience with architecting distributed systems on top of Kubernetes, and I use the Google Kubernetes engine, GKE. So a lot of the nice features that Google provides, I was able to benefit from. And currently, I work for a startup company called Helix.com, which is in the space of consumer genomics, DNA sequencing, etc. And my next project, starting maybe in next week or in 2 weeks, is to evaluate AWS KS, which is the elastic Kubernetes system from Amazon, to transition our infrastructure into Kubernetes. And I'm also a Jiu-Jitsu blue belt, so this is another way to identify me. So let's get on with the actual talk. And what we'll cover today, so you can see this is a pretty dense slide. So we talk about the Kubernetes extensibility landscape, what can be extended with Kubernetes. Then we'll talk about custom resources, which is the most common way and easy way to extend Kubernetes. We'll go into more advanced topics like API server aggregation, different types of plugins. So CNI plugins allows you to completely control and customize the way Kubernetes networking works. CSI plugins allow you to plug any type of storage into Kubernetes on top of all the built-in storage options. Device plugins is something pretty new. So you can actually manage using Kubernetes all kind of additional devices like GPUs and network cards and FPGAs. So this is still very young area, but very promising. Then we'll talk a lot about access control webhooks. So there are different ways to control access to Kubernetes resources. So there is the AAA, Authentication, Authorization, and Admission. We'll talk about the webhook option. Then custom scheduler plugins. So the main function of Kubernetes is to schedule pods to different instances, nodes, right? It could be a physical machines or a virtual machines, but this is the primary function of Kubernetes. And you can actually replace the scheduling algorithm with your own algorithm or even run side by side. Then another area is custom metrics for horizontal pod auto-scaling, which is another very cool feature of Kubernetes, that it can automatically scale your infrastructure based on different metrics. So the common ones are CPU or memory, right? So if you run out of a CPU or 100% CPU or close to 100%, or running out of memory, then Kubernetes can automatically add more nodes to your service and then extend the capacity. But as we'll see later, there are other metrics that could be useful for that beyond the CPU and memory. And finally, I'll talk a little bit about kubectl plugins. So kubectl is the command line interface to Kubernetes, and extending it with your own plugins provides a really smooth and streamlined working environment, especially when you extend Kubernetes itself with other resources and components. So let's move on. And let's look at the Kubernetes extensibility landscape. So Kubernetes, it's made of several big parts. There is the Kubernetes control plane. So this is the API server itself, and it stores the state in a etcd distributed database. And the actual workloads, they run on different nodes inside pods. So on each node, each machine or virtual machine, there is something called the kubelet. So kubelet is an agent that Kubernetes installs on each such node. And then through this kubelet, Kubernetes can schedule pods to run there. And the logic and all the extensions and plugins that run in the kubelet, that they control what happens on this particular node. So a kubelet can interact with a Webhook backend. So this is one option for extending Kubernetes, which means that when the kubelet needs to verify or check something, and we'll see examples later, it actually hits some remote endpoint, and the decision happens there. And then the kubelet applies the decision to what's going on the node itself. Another option to extend the Kubernetes is to have a binary plugin that integrates with the kubelet itself. So we'll see also different options for plugins. There are plugins that are built in, there are plugins that are dynamic plugins, and then there is also gRPC plugins. And another option that is very common is to run on the node a controller. So a controller runs actually inside a pod, and Kubernetes manages it just like any other pod, except that it's locked in to a specific node. So there is always one running on each node. So it could be done through a daemon set or through other Kubernetes features like taints and tolerations, etc. But this controller can watch and listen for different events and then react, and this way extend the functionality and what Kubernetes actually does. So those are the different dimensions to extend Kubernetes. And let's start with custom resources. So custom resources are resources that you define. And the cool thing about them is that you pretty much get an API server and a database for free. So your own resources will be stored by Kubernetes in etcd, and you will get automatically various CRUD REST endpoints. So you can create, get, update the list, and list your own resources. You get versioning, so you can version your resources if you have multiple versions that you want to evolve your own custom resources. And then you have watches, so you can watch changes to and respond to them. So this is pretty much goes hand in hand with controllers. So a very common pattern with people that extend Kubernetes that they define some custom resources, and we'll see some examples later. And then they also create controllers that watch for events on their own resources and then respond and react. And there is a nice project called the Kube Builder that allows you to build your own APIs and gives you a lot of boilerplate. Okay, so let's look at an example of a custom resource definition. So as you can see, it's a YAML file similar to other Kubernetes manifests. And we got some metadata here. So in this case, I define a resource that's called candies. And the name, it has some format requirements. So the name of the resource should be plural, for example. And then you have the spec, the specification of the resource that identifies with a particular group and versions. And the reason for this kind of well-defined format is that it can work later as part of Kubernetes itself, because it follows the same naming conventions and the same attributes. So we see here, for example, the name. So the name, the plural is candies, and then the singular is candy. You can specify the singular because Kubernetes is not necessarily very good at grammar, and you can't tell how to convert the plural name to a singular name. And then there is a kind, which is kind of the type of the type. And finally, you can even have short names, right? So, for example, in Kubernetes, if you want to do in the kubectl, if you want to do a get pods, you can also do get PO, just a short name. So you have the option to give short names to your own custom resources too. So that's part of the streamlined integration with the rest of the Kubernetes experience. So here for candies, I selected CN as a short name. And now we can see, so working with candies or with custom resources. So you can see here I define this candy.yaml file. And here I define one specific candy, right? So we have the API version. We have the kind, which is candy. We have some metadata that can be anything. In this case, I chose a name, which is chocolate. And then in the spec, I define the flavor, sweet. And then we use just the normal kubectl create command to create this resource. And then we see that the resource was created. And now here you can see that I can use kubectl, and now it's already integrated with my custom resource. I can do get candies, and then it gives me back my my chocolate. All right. So we can also use here the other capabilities of kubectl. So here in this case, I use the command with the short name. So I do get cn, and as output, I request the JSON output. So that gives me a much more detailed output than the normal, just the default get command. And you can see here that we have the version, we have items, we have a self-link in case we want to access it, those resources programmatically through some REST interface. And there is a unified ID. And also we can see that the kind here is a list. So this is a list of the resources. Okay, moving on. So custom resources are cool, but they have some limitations, but they are very easy to use. You just pretty much work with YAML files, and then everything happens just on its own. If you want more control and more customization of the resources, more operations, for example, maybe you don't want just CRUD, maybe you want additional operations like exec or scale, then you can use API server aggregation. Here you use the same API machinery like Kubernetes itself. So it's still managed by Kubernetes, but you write your own API server really. So the integration is very seamless from the user point of view. It's going to be almost as if Kubernetes is running everything, but you control the storage of the resources. So it's not going into etcd automatically. And you have to actually write some Go code to implement it. Another benefit is that you can have multiple versions of the same resource when you manage it yourself. With custom resources, there is just one version at a time. And finally, the payload of your resources, you can use a protobuf, so Google protocol buffers, which is a very efficient and performant format. While with custom resources, you have to use a JSON pretty much. So that's API server aggregation, another option. And now moving on to plugins, so CNI plugins. So what's really a CNI plugin? If you want to add the network interface to your container network and you want to control how information flows between your containers. So you can do various types of bridging between the host and the container itself, because the whole point of the Kubernetes networking model is that pods are really can see each other. So it's a completely flat networking space, even though the actual physical network and the configuration can be very complicated. But from a a Kubernetes user or developer point of view, all pods can just see each other. So in order to control it in different networking environments, you can implement your own plugin that defines how those IP addresses for the pods are assigned and how the traffic is routed between those different containers and pods. So you can see here in this diagram that the container runtime, it talks to the CNI plugin, and then underneath the CNI network interface, and through this interface, many types of plugins can be defined, and they all have their own specific attributes, and they are suitable to different situations. So some of those are built into with Kubernetes, and then you have also third-party plugins that you can define yourself. So what's really the interface of a CNI plugin? So it's very simple. You can add a container to your network, you can remove a container from your network, and you can report a version. That's all it is. And the command line interface, and then the interface is very interesting. So it's a command line interface. You run your plugin as you execute it, and you provide the input through just standard input and environment variables. And the main and the most important argument that you pass is your network configuration, which is a JSON blob that we'll see soon. So here are some of the environment variables that you define in order to control your plugin. So there is the operation that you want to perform. So is it add or delete or a version? And then CNI path is where Kubernetes should look for your CNI plugin executables. And then network namespace file and interface, and a few, you can have even extra arguments. So pretty much you control things with environment variables. And this is an example of the network configuration that you pass through a standard input. So you can see there is the version here, and the name, and the types. In this case, it's bridge, and IPAM. So that's the IP address management. So you can see all kind of networking level parameters here, right? So subnets, and the gateway, and the DNS, etc. So there is a lot of nuances and details here. So if you're interested, I encourage you to read up on it. Here we're just skimming over the capabilities. We're not going to get into details. So that's the network configuration. And the next type of plugin is CSI plugin. So this is a common storage interface, and this is an industry-wide standard. So it's not just for Kubernetes, but Kubernetes is probably the most prominent user of CSI plugins, or at least is going to be. And the idea is that Kubernetes already has a lot of plugins for storage, but a new storage type or vendors of storage equipment may want to define their own plugins. So before CSI was adopted by Kubernetes, you had to integrate it into upstream Kubernetes. So you had to create your code and follow all the requirements of integrating new code and get it reviewed by Kubernetes engineers, and it was a pretty tiresome and long process. So with this new CSI standard, you define your own plugin, and there is a way to communicate between Kubernetes and your plugin across gRPC. So that the reason that using gRPC is that you don't have to compile it and build it and link it with the Kubernetes code base itself, which is both could cause performance and security issues, as well as it takes more knowledge. So by separating them and having a gRPC interface between them, they're kind of more isolated, and it's easier to implement, and the Kubernetes engineers don't have to worry too much about the damage that some storage plugin can do. Worst case, they can always just cut it off and say, okay, this storage is dysfunctional at this point. So it's a huge improvement over the previous way to do custom plugins, which was flex volumes. And it will, I think it will have a great ecosystem of new storage options integrated easily with Kubernetes. So here is a pretty complicated diagram of CSI plugins, and you can see that here at the bottom, if you see the legend, and the green components are Kubernetes components that are part of the CSI infrastructure. And the orange components, for example, here we have an NFS CSI volume. So those components are created by the vendor or whoever is the developer of this storage option, and the communication goes over gRPC. So in this case, we see on the left side, we see an option where the storage goes to some central network storage. On the right side, so this is a daemon set in this case. On the right side, we see a stateful set where the storage is actual local storage. So we have here empty DO volume, and it all communicates and coordinates the storage option through the gRPC API and through the CSI infrastructure. And here on the completely on the right side, you can see how this CSI attacher talks to the API server. So the Kubernetes is completely unaware of what's going on with the storage. It only understands the CSI. It talks to a CSI attacher, which then talks through gRPC with the actual storage plugin. So it's a very elegant design. Okay, so device plugins, I couldn't find any real examples. So there are some vendors that already created device plugins. The idea is to have Kubernetes manage all kinds of custom resources beyond just pods and nodes and the network, which those are resources that the Kubernetes is internally aware of, but other more specialized components like GPUs and different network cards and FPGAs. So similar concept to the CSI plugin that we saw before. So the kubelet provides a gRPC service that all kinds of devices can be registered, and then the device plugin is deployed on each node that wants to utilize those special resources. So they are deployed as a daemon set, which means there is one per node in the cluster. And then the pods can just request this resource in their spec. So here we can see an example here. We have a pod called the demo pod. And then here in the resources, it's a request. Okay, so that's for limits. So I need to go to the next page. Oh, okay. So actually, this is the wrong one. Oh, here we go. Yeah, so vendor domain and resource. So this is where it's requesting some custom resource based on the vendor domain. So that's not a built-in Kubernetes resource. And there must be a plugin, a device plugin underneath that knows how to service those requests. So very new, and it may also be a great way for Kubernetes to extend its ability to handle different workloads on different devices. Okay, so now moving on to access control. And Kubernetes was always had a very sophisticated access control methods, but it was very difficult to integrate custom access control methods because the details were very gnarly, and you had to really understand both the domain and also how to build it into a Kubernetes. So it required building your own controllers and having a lot of in-depth knowledge of Kubernetes mechanics and internals of the API server. So a new option to make it much easier is to use webhooks. So here we're looking at the first pillar of access control, which is authentication. And by having a remote webhook, you can have pretty much a web server or an access authentication server that runs completely independently of Kubernetes. And you can use any authentication method that you want. You can just implement whatever you want. And through this webhook interface, you can, every authentication request goes to this remote authentication service through the webhook, and then it returns just a response. If this particular individual or service or whatever agent it's trying to authenticate, if it's authenticated or not. So this is just identifying specific agents that want to interact with Kubernetes, and the way the Kubernetes itself authenticates the remote auth server is through just a standard SSL. So we have a certificate authority and client certs, etc. So it's using best practices, because if your own authentication server is compromised, then obviously the entire cluster is compromised. So this is the authentication, and you can configure the API server to work with a remote authentication server with a YAML file that's similar to the kube-config file. And capabilities that are supported, advanced capabilities are impersonation, so you can configure the remote authentication server to allow users to impersonate other users or other services, and also anonymous requests, which is also useful sometimes. So here's an example of the config file for the authentication webhook. So we can see here that there are clusters. Which cluster are we talking about? And then we have here the file for the CA, the certificate authority. We have the URL for the URL for, sorry, that's jumping up, can't select. So the URL for the remote authentication server. And then, so the user section is the user of the remote authentication server. The client of this remote authentication server is Kubernetes itself. So it's not the end users here, but it's the API server. And then we have here the client certificate and the client key that Kubernetes will present to the remote authentication server to authenticate itself. And finally, we have the webhook and the context. So we have the context of this authentication procedure, and then the user is the class. So this is pretty much repeating the context, repeating the information there. And the next phase, so once we authenticated the user, right, the request comes in, we authenticate the user who's requesting to perform this action. The next thing is authorization, right? So maybe we know who this user is, and we can authenticate it, but now he's requesting some operation that is not allowed to do. So this is the authorization phase of the whole access control. And it's really pretty similar to authentication. So with webhooks, before it was very complicated and you had to integrate tightly with Kubernetes. Now you can just implement your own authentication server. And we can see here an example of authorization request, right? So the kind is a subject access review. And you can see that it's going into this authorization API group. So then we have here, so the spec of this request is, okay, what are we asking to access? So this is the resource, so which namespace, what are we trying to do, what verb, so it's a get. And then here we're trying to get pods from this particular group, and then we have here the user. So this is already the authenticated user, and as part of the authentication, we also got the groups that the user belongs to. So here we see that this user mark belongs to the group developers and testers, and based on information, the remote authorization server will return a response, which will pretty much is very simple. You have a status, and then there is here allowed, and it's either going to be true or false. So that's all there is to it. And then Kubernetes will reject, if it's true, the Kubernetes will allow it to move forward, and if it's false, then it will reject it with a for tree. And finally, so this is something that's not very common. You don't see it in many access control systems, but Kubernetes also has a phase called admission. So admission, once a request is already authenticated and authorized, still there is another phase, and it applies only when you're trying to mutate resources. So if you're just making a read-only request, right, you're trying to get some pods, once you authorize, you're done. Your request will be granted and you get a response. But if you're trying to create or delete or modify some existing resource, you still need to go through this admission phase. And here there are two types of admission. One of them is validation. So validating that you can modify this resource. And the reason that validation can fail is not because you're not allowed, because this part is already done during authorization, but maybe there is no, for example, maybe you try to create a new pod and the cluster is at max capacity, just you're unable to create this resource that you're asking to create. So validation can fail. And mutating admission is another phase where your request can be changed. For example, maybe you're asking to create a new pod, but then the admission plugin or the admission remote server decides that some other operation needs to take place in addition. For example, maybe someone needs to be notified, or maybe some record should be stored somewhere for audit purposes. So that's additional things that admission can do. So again, it's optional, but it has been useful for many real-world scenarios. So there is this admission phase. And the mechanics are really very similar. It's just, again, remote requests, and then Kubernetes will do something in a response. Okay, and then the next thing is a custom scheduler plugin. So I talked about it a little bit at the beginning, but scheduling pods to nodes, this is the core function of Kubernetes. If you want to define Kubernetes in one word, it's a scheduler for container workloads. So the built-in Kubernetes scheduling algorithm is super complicated and advanced. It takes into account policies, it's topology aware, and it's resource aware. And there are so many ways where you can kind of just the basic scheduling algorithm, you can control it with many different attributes and policies, and defining limitations and constraints on different on the different options Kubernetes can schedule. But still, some users have needs that go even beyond that. And for that, Kubernetes gives you the option to completely replace the scheduling algorithm with your own algorithm. So you can take all those resources that are stored in the API server and just decide for yourself when a request comes in for creating a new pod, when an existing pod crashes and you need to schedule it into a new node, then it can be done by your own custom algorithm. But this is not all. You can also have it run side by side. So for example, you can have the default Kubernetes scheduling algorithm schedule most workloads, but then you just hook your own algorithm in, and when you decide that a particular request comes in, that you want to schedule this particular pod based on different metadata options and tags that comes in with the pod, for example. So right now, you still have to integrate it as far as kind of write your own Go code that implements a particular interface, and then integrate it, build it in to Kubernetes and provide it when you start Kubernetes itself. But there are talks about having a webhook option also in the future, so it will be easier to integrate. Okay, moving on. So I think this is our last item, which is custom metrics for horizontal pod autoscaling. So this is one of, I think, of the coolest features of Kubernetes. Every non-trivial DevOps operations, scaling and auto-scaling is always a very hard task, and you need to build a lot of support and infrastructure for it. So with Kubernetes, there's really a very solid foundation. It already works great for CPU and memory. But if you want to do your auto-scaling based on something else, for example, let's say your workload is DB constrained, right? So when, for example, when you cross some thresholds of requests per second, then your whole system begins to slow down, and maybe you want to schedule more database nodes, or maybe schedule more caching, depending on your architecture. This is where those custom metrics come in. So you can define ways to scale different pods based on your own custom metrics. And there is here a good example of the custom metrics API server, which is pretty much a built-in server that lets you add your own metrics very easily. So here is an example of the custom metrics interface. So at the end, we can see some Go code just for fun. So you can see you have here different methods that you need to implement in order to select, to let Kubernetes select those metrics. And you can even list all your metrics. And based on this interface, if you implement it, then Kubernetes will be able to automatically scale different pods and without your explicit involvement. So that's great for self-healing and self-auto-scaling systems. Down. Okay. Oh, so we still have yeah, this is the last one, almost the one before last. So kubectl plugin. So kubectl, if you're familiar with Kubernetes, this is your go-to tool to control everything from your local machine. You can interact with Kubernetes very easily. I mean, there are many good UI and web UI options, but this is really an indispensable tool when developing and working with Kubernetes. So since we talked a lot about extending it and adding new capabilities, then you can also extend kubectl itself. And this is great. Let's think about, for example, let's say you have something to provision new nodes for the cluster. Right? So Kubernetes can auto-scale pods within your cluster, but if you need more capacity, then this is something that goes beyond the Kubernetes itself. So you can integrate this ability into a kubectl. So you have a single uniform interface, and you can add your own command to do pretty much anything, and you get the whole kubectl command line experience. And it's very easy to add new plugins. So we'll see an example here. So it's just another YAML file. And here is something, just an example I took from Kubernetes itself. So here is an hello plugin. So you see, this is just, the name is hello. So if you write kubectl hello, it will run this command, which is just echo hello plugins, and that's all it is. And then you get the help. So the short description as part of the help. If you try to look for help on this command, then it will give you I say hello, and it's super easy to implement and make kubectl work for you. Okay, and then this is the final plugin. So I'm going to plug in my own book. So if you want to know more about Kubernetes and really dive deep into all the advanced stuff and many of the things that I just covered briefly here, then you can get my book, and I go into a lot of detail there, and it's pretty up to date. The second edition is, I think it's up to version 1.10, so it's very, very current. And that's it. So if you have questions or any other comments, then let me get back to I'll stop sharing now and I'll go back to the chat. How are we doing on time? Pretty good. Okay. So I'll just read the questions and then I'll answer them here. So one question here. Do you know what is the difference between a KubeBuilder and the operator SDK from CoreOS? So the answer is I don't know exactly the differences. I read a little bit about both, but I didn't really dive in, and I definitely didn't do any work with them. So I always hesitate to talk about things that I don't have hands-on experience. So, but in general, I think both of them are valid tools and people use them. So if you're interested, definitely, I think you can't go wrong with either one. But I think that in general, the operator kind of paradigm from CoreOS, it becomes more prominent, and people really gravitate more to this model of creating operators on top of Kubernetes. Okay, another question. Oh, it's the same question. Okay, so do you get the request payload from the user on the admission webhook or authorization webhook? So you can have access to the payload, and it's necessary during authorization, because sometimes your authorization decision is going to be based on the actual payload, because sometimes the payload defines what really will happen when processing the request. So yeah, the answer is you can get access to the payload. And don't see any other questions.
That's it.
All right.